Hello, my friends. I'm Clover, and this is a puzzle called 6-6 by Philip Newman. So this was Philip's puzzle posted on June 6th. I know I'm a little bit behind on these walkthroughs. I have been horrifically ill for the last week or so I'm feeling a bit better now. As you can probably tell, I'm about to go through and catch up on walkthroughs over the next couple of days, so you'll be getting a few at once from me in the near future. But let's focus on this one for now. This was posted June 6th, and it is a Little Killer Math Pairs Sudoku. So normal Sudoku rules apply. We're placing the digits 1 through 9, once each, in each row, each column, and each outlined 3x3 region. There are some little killer clues outside of the grid. Those tell us that the sum of the digits along each of these diagonals that are marked with an arrow is 6. And then the math pairs tell you about the mathematical relationship between the two digits in the adjacent cells. So for instance, one of these cells contains a digit that when you divide it by the other one gives you 6. One of these cells, when you subtract the other one, gives you 6. One of these cells, when you add the other one, gives you 6, and so on. So we can pencil mark quite a few of these. For instance, the only two Sudoku digits where if you take one of them and divide it by the other, you get a result of 6. Are 1 and 6. There is not any other valid way to do that. With multiplying to get to 6, we have to either do 1 and 6 or 2 and 3. And with addition to get to 6, our options are 1 and 5 or 2 and 4. And there are a few more options for the 6 minus. We can also pencil mark some of these little killer clues. This has to be either 1 plus 5 or 2 plus 4, and because there is a 1-6 pair in the region, that's going to be 2 plus 4. Ditto down here. And let's start doing a little bit of Sudoku before we continue with the remaining clues, particularly those 6 minus clues and the longer little killers. So you can't have a 6 subtracting something else to yield a 6 in Sudoku. You don't have the right digits for it. So this has to be a 1 with 7 minus 1 equaling 6. So that's going to be my 1, 7, and a 6. Now, to do a subtraction of 6, so a difference of 6 between the two digits, we have to have either 1 and 7, 2 and 8, or 3 and 9. We've used 1, and we've also used 2 in this pair here. So this has to be 3 and 9, meaning our last two digits here are 5 and 8. Now we're ready to look at this 6 little killer clue, because the lowest these two could be is 1 plus 3, which is 4, which leaves us room only to do 1 and 1 on the outside. So 1 plus 1 plus 3 plus 1 is in fact 6. So that's going to be a 9. We can't use a 1 in this sum anymore, so this is going to be 2 plus 4. We can't use a 1 in this sum anymore, so this is also going to be 2 plus 4. And we're going to get something very similar here. So here we can't use a 1 or a 2 in the 6 minus, so just like above we get a 3, 9. And that tells us that this has to be minimal 1, 1, 3, 1, which makes this a 7 to fulfill the 6 minus clue. This also is going to be a 7 because 7 minus 1 is 6, and we can't use a 1 in this clue, so that is a 2, 4 pair. These two remaining digits in the region are going to be 5 and 8. Now we have a 2, 4 pair vertically in column 5. That lets us eliminate 2 from these cells, which means that can't be 2 times 3. It has to be 1 times 6, which shakes out like this because we have a 1 in row 6 already. That makes this a 7 because 7 minus 1 is 6. Now one of these is going to have to be 8 minus 2, and one of them will have to be 3 minus 9. So that's 4 digits that are used up in the row. The remaining digits are going to be 4, 5, 6, and 7. We can't have a 4 or a 6 here because those are already represented in the region. And so these can't be 5 or 7. That's a 4, 6 pair. The difference of these guys is going to be 6. Can't be 1 and 7. We've used those in the row already. So that must be 2 and 8 or 3 and 9. And we don't know which as of yet. This guy can't be a 2 because there is a 2 in the region. And these have to be 3, 8, and 9 in some unknown order. And because that can't be a 2, the one next to it cannot be an 8. Now, what was our next move here? Let's see. What do we still need? This is going to have to be a 2 and an 8, making that a 5 and a 4. which resolves quite a bit via Sudoku. This is now an 8-9 pair. The 4 and the 2 are resolved. This has to be either a 2 or a 3. And we can pencil in the remainder of these columns. This is going to be 2, 6, 7. That we can see as a naked 6. And this is going to be 1, 8, 9. This can't be a 9. Those can't be 1s. That's in fact a 1. That leaves us with 5 and 8 to finish off this row. And here we're going to need 3 and 4. This difference is also 2 and 8. That's 5 and 4. And that lets us resolve quite a bit of Sudoku over here. Now I need a 3, 5 pair here. And 6, 7, 9 to finish the region, which gives us a naked 9 right there. Here I need to place an 8 in the column somewhere. Can't go in the top because there's an 8 in row 1 already. So that's going to be my 8. And then this digit has to be either a 3 or a 5. Along this row, I need a 5, an 8, and a 9. And the 8 can't go here because there's an 8 right below it. Here I have a 4, so the 4, 6 is resolved. And in this column, I'm going to need to finish up with 2, 3, 5, and 7. That can't be 2, 3, or 7, so that is a naked 5, which keeps me from placing a 5 in this cell. Therefore, 5 in the region goes there. That makes this a 9 and makes this an 8. I can eliminate 8 and 9 from right here. So that's 2 or 3. The digit it goes with is either 8 or 9. This is not a 7 because there is, in fact, a 7 in the region now. The last 2 cells in this region are going to be 4 and 5. And in this row, I need a 1, a 6, and an 8. That has to be my 6 because there's a 1 and 8 in the region. So that's an 8 and that's a 1. That makes this a 9 and finally tells us which way around these differences go in row 5. And there's a 2 in the top row, so that's going to be a 7 and a 2. The 6 I've placed in column 6 resolves this. Those can't be 2 or 4, so that's 5 and 9. And that should take care of everything and let us finish off the puzzle using classic Sudoku. And that's a 9 and a 5, and this is 4 and 9, 2 and 8, and I need a 3 and a 6 to finish. And that is how you solve Philip Newman's lovely 6-6. Hope you guys all enjoyed that one. The link to check it out yourself is in the description of this video, and I will see you again in a couple days.